Chemistry of carbon compounds. Introduction. Organic chemistry is the chemistry of carbon compounds. Carbon 12, 6, atomic number 6, mass number 12. Electronic configuration 2, 4, 1s2, 2s2, 2p2. Valency of C is 4. Catenating power. Catenating power is an unusual property of carbon atom. That is, ability of carbon to form covalent bonds with other carbon atoms to form chains and rings. Carbon atom can share 4 valence electrons with the elements like hydrogen, oxygen, nitrogen, sulfur, phosphorus and halogens and forms a number of compounds. The diagram shows bonding of carbon atoms in a straight chain, branched chain and a closed chain. Importance of organic chemistry. Organic chemistry is a field of immense importance and plays an important role in our daily life. The food we eat like fat, carbohydrates and proteins, wood, fuel like coal, petrol, kerosene, LPG, perfumes, cosmetics, paints, plastic, dyes, drugs, rubber, insecticides, paper and ink all are organic substances. Many fundamental phases of agriculture, biological processes, functioning of animals and plants can be studied and understood with the help of organic chemistry. General characteristics of organic compound. Organic compound besides carbon contains hydrogen, oxygen, nitrogen, sulfur and phosphorus and rarely metals. In organic compounds, carbon atoms are joined together by covalent bonds. The number of organic compounds known is too large due to the catenation property of the carbon atom. Organic compounds show phenomenon of isomerism, same molecular but different structural formula. Organic compounds show phenomenon of polymerization, in which number of small units add up to form a large molecule called polymer. For example, polythene. They are insoluble in water but soluble in organic solvents like benzene, alcohol, ether, etc. They have a relatively low melting and boiling point because of the covalent nature. They burn readily with few exceptions like carbon tetrachloride, CCl4. Organic compounds are combustible in nature. Most of the organic compounds have a characteristic odor. For example, esters have sweet and a pleasant odor. An atom or a group of atoms that gives characteristic properties is known as a functional group. Classification of organic compounds. Organic compounds are classified into aliphatic or acyclic or open chain compounds and cyclic or ring or closed chain compounds. The cyclic compounds are further classified into homocyclic or carbocyclic compounds and heterocyclic compounds. The homocyclic compounds are further classified into alicyclic compounds and aromatic compounds. Aliphatic or open chain compounds. Organic compounds in which carbon atoms are joined to form an open chain are called aliphatic compounds. For example, pentane, isobutane. Closed chain or cyclic or ring compounds. The organic compounds in which carbon atoms are joined to form a closed ring are called as cyclic compounds. They are further subdivided into homocyclic or carbocyclic and heterocyclic. Homocyclic compounds. Homocyclic compounds contain a ring of carbon atoms only. They are further subdivided into alicyclic and aromatic. Alicyclic compounds. They are composed of ring of carbon atoms having properties similar to those of aliphatic compounds. For example, cyclopropane and cyclopentane. Aromatic compounds. Cyclic compound having 6-membered ring of carbon with alternate single and double bond. Benzene is the simplest aromatic hydrocarbon. Examples are benzene, toluene and naphthalene. Heterocyclic compounds. These are ring compounds where one or more atoms other than carbon, like oxygen, nitrogen, sulfur, are present in the ring. For example, thiophene and furan. Classification of organic compounds based on the functional group. Functional group. An atom or group of atoms which defines the structure and also determines the chemical properties is called a functional group. The table showing classification of organic compounds based on the functional group is given. Alkanes, saturated. Example, ethane. Alkenes, unsaturated. Example, ethene. Alkynes, unsaturated. Example, ethyne. Alkyl halide. Example, methyl bromide. Alcohols. Example, methyl alcohol. Phenols. Example, phenol. Amines. Example, ethylamine. Ethers. Example, dimethyl ether. Aldehydes. Example, acetaldehyde. Ketones. Example, acetone. Carbocyclic acid. Example, acetic acid. Esters. Example, ethyl acetate. Amides. Example, acetamide. Acid anhydrous. Example, acetic anhydride. Cyanides or nitriles. Example, methyl cyanide. Isocyanides. Example, ethyl isocyanide. Nitro compound. Example, nitroethane. Acyl chlorides. Example, acetyl chloride. Classification of aliphatic hydrocarbons. Hydrocarbons are organic compounds which contain only one carbon and hydrogen atoms. They are alkanes, alkenes and alkynes. Homologous series. A series of organic compounds which can be represented by same general formula and have same functional group in which each compound differs from its previous and next compound by CH2 group is called homologous series. The individual member of homologous series is known as a homologue. Example: homologous series of alkanes: methane, ethane, propane, butane and pentane. Characteristics of homologous series. All the members of the homologous series can be represented by the same general formula. All the members of the homologous series contain the same functional group, hence similar chemical properties. Each member differs from its previous and the next member by a CH2, that is a methylene group. That is, they differ in molecular weight by 14 units. All the members of the homologous series can be prepared by similar methods of preparation. The compounds from the series show gradation in physical properties such as melting point, boiling point, density, etc. Empirical and molecular formulae of organic compounds. Molecular formula. The formula which gives the actual number of atoms of different elements present in the molecule of a given compound is called a molecular formula. For example, molecular formula of benzene is C6H6. Molecular formula weight. The sum of the atomic weights of atoms in the molecular formula gives the molecular formula weight of the compound. For example, molecular formula weight of benzene C6H6 is equal to 12 into 6 plus 1 into 6, which is equal to 78. Structural formula. The formula which gives the exact arrangement of the atoms of different elements present in a molecule is called a structural formula. Structural formula of ethane is given below. Empirical formula. the formula which gives the simplest whole number ratio of the atoms of different elements present in the molecule of a compound is called the empirical formula. For example, empirical formula of benzene C6H6 is CH. Empirical formula weight. The sum of atomic weights of the atoms present in the empirical formula gives empirical formula weight of the compound. For example, empirical formula weight of CH is 13. Relation between molecular formula and empirical formula. Molecular formula is equal to N into empirical formula, where N is equal to molecular formula weight upon empirical formula weight. Determination of empirical formula of the compound. Step 1. To find the percentage of each element present in the compound. If sum of percentage of given elements is not equal to 100, then remaining percentage is the percentage of oxygen. Step 2. To get the atomic ratio. For this purpose, percentage of each element is divided by its atomic weight. Step 3. To get simple atomic ratio. The numbers obtained in step 2 are divided by smallest of these numbers. Step 4. To get whole number of each element present. For this purpose, minor fractions are neglected. If required, they are further changed to whole numbers by multiplying them with a suitable factor. Step 5. Finally, empirical formula is obtained by writing symbols of different elements side by side along with whole numbers obtained in the step 4.